Leetcode practice time. In this video there are two goals. So the first goal is to see how to solve this problem. So you're going to see how to solve this problem, and then we are going to put some coding work here. And the second goal is to see how to behave in a real interview. So let's get started. So remember, in a real interview, the first step is always try to understand the problem. If there's anything unclear, please bring up the question, and at the same time think about some edge cases. So let's take a look at this question. Given an m by n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. So example, like this, we have the input matrix. So the output is gonna be 4. Okay, so why it is 4? That is because this one or this one is the largest matrix. Okay. Similarly, for this one, it is going to return 1. This one return 0. Okay, so I think I mostly understand the problem. Let's see how to solve this problem. Before we find the general solution, let's take a look at the constraints. It says that m by n is within 1 to 300, so for sure it is not going to be an empty matrix, and all the elements are just 0 or 1, so we don't need to worry about the illegal input. So let's see how to solve this problem then. So this seems to be a DP problem. So for DP problem, we need to find the decompose the original question and to find the DP formula. So what will be the DP formula for this? I have a sense that this is a DP question. So let's say if dpij, let's say dpij is what? So first of all, we need to define the dpij. So let's say we define the dpij as a maximum square. So if you want to compute this, so what matters, I think based on the graph, what matters is this one, and this one. Yeah, so I think I have an idea about this. So let's see. So if it is, so dpij, so if the matrix I and j is equal to 0, then we just ignore it. Otherwise, if it is not equal to 0, it is a 1, then it is dependent. So the size of the matrix depend on this part, the maximum size of the matrix, which we compute at this point, ending this as a bottom right corner, and also this ending with this as the bottom right corner, and this ending with this element as the bottom right corner. So let's say we define the dp ij as the length of the maximum square. So for this one, the maximum length is 1. This one, the maximum length is 2. This one, the maximum length is 1 as well. So it really depends on the smallest element within those two, within those three numbers in the DP. We are already computed. So it will be something like, I would say, if it is depending on the DP, mass.min, or just min. I would say it's else. It's min dp i-1j and dp I j minus 1, and this is dp I minus 1 and j minus 1. So this is the min plus 1, something like this. So having said that, let's do some coding work. So for this one, the runtime is going to be O m by n, and the space is also going to be O m by n. So let's do some coding work. So for coding, we care about the speed, don't be too slow, and also the correctness of the code and the readability of the code. So let's see. First of all, we define the DP array as equal to new. Let's first have the row and the column. So let's say this is the length, and int column is equal to matrix 0.length, and dpij, sorry, the dp is with the size as row and column. Yeah, so we are going to initialize the dp with the first row and first column. So I will say int I is equal to 0, I is smaller than row, and plus plus I. You have dp I 0 as equal to this is matrix I 0 equal to 0. If yes, then it is 0, otherwise it is 1. Similarly, we are going to initialize the first row. So int j is equal to 0, j is smaller than okay, so this is 4, j is smaller than the column plus plus the j, and we have the dp 0 j as equal to matrix 0 j is equal to 0. If yes, then it is 0, otherwise it is 1. So that's pretty much it about this initialization, and next part is more about the computation. Okay, so we actually need to have the largest square re ln as equal to 0. So I would say if any of them is 1, then we should initialize that as 1. Or maybe you could do this. If matrix no, not really. So largest square length. Okay, so largest square length is equal to max largest square length and the dp I 0. Yeah, so this is 0 and j. So int I is equal to 1 as smaller than row, the plus plus I, j is equal to 1, j is smaller than the column, and the plus plus j. So we are going to say, alright, so dpij is actually max dot min dp I minus 1 j, and dp I j minus 1, and we have max dot min. Yeah, so this is dp I minus 1 j minus 1, and plus 1. So okay, so we need to say if matrix ij is equal to the 0, then we just need to continue. Otherwise we just need to we need to compute the dpij. So here again we are going to have this one set as dp max of the dpij or the current max. And finally, we are going to return the size of the maximum square. So having said that, let's take a look at the code, and also we will run through some test cases. After you're done with the coding, you need to go through some test cases, explain how this piece of code is gonna work, and also at the same time do some sanity check. So for this one, let's see, let's just use this case. So at the very beginning, we initialize this as 10100111 for the DP. When we compute this part, this is going to be 0. this is going to be 1 because the smallest among all of them is 0. So for this one it is also 1. This one it is also a 1. So for this, when you compute this part, and we compute this as 1, this as 1 as well, this one as 1, when we compute this part, we see that those three things are 1, then we have this is set as 2 when we compute the corresponding position for the DP array. And finally, we should have the largest square length as 2, and we return 4. So I think overall it should work well. Let's give it a shot. So it's new, okay, so new int. This is some typo here. Alright, so seems like it's working. Let's give it a submission. Alright, so it seems like everything is working. So I think runtime wise, this is already the best. And usually for some DP problem, like DP problem on the matrix, we can do some space optimization. Let's say instead of having like a DP matrix, we can have a DP row, and because so the thing is, because based on the DP formula, when we compute the DP value for this component, it's mainly based on the previous row. Essentially, it's based on those three elements. So it's mainly based on the previous row and the current row. So we can just instead of creating a matrix, we can just create a temporary array. So that one we should be able to save some space. But I'm not going to get there. I'll just leave the optimization for you to do it. So that's it for this coding question. If you have any question about the puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.